Gentlemen, welcome back. Last week I blew up a $40,000 relay test set. Just let all the magic smoke out. I'm going to bury the lead a little bit here and talk about that in just a second. Note that this video is much less magnum opus and much more old man yells at clouds. But I really want to get two things across on this video. Number one, I want to make relay technicians out in the field aware of a really stupid design decision that a lot of engineers are making lately. I don't understand why. And number two, I want to make a plea to said engineers to stop doing said stupid thing. I assume a lot of my audience is already aware of what test switches are and how they work, but I feel that this story is going to be a lot more emphatic with some background information. So we're going to start there. Westinghouse started making electromechanical protection relays with the Flexitest switch system back in the 1960s. Now, I'm not sure if the CO relay was one of the first ones to have them, but obviously they were a huge improvement at the time. We could conveniently isolate and test the relays in the field inside the case. The FT cases quickly became incredibly popular and stayed popular for decades. These test switches were built directly into the FT style relay chassis, into the bucket that enclosed the relay, for connecting the CT secondary circuits, the voltage circuits from the PTs, trip circuits from the switchgear or from the substation yard. Test switches allowed the relay to be completely disconnected for maintenance and testing by opening them up, and then you could slide the guts of the relay out. But they also provided a convenient spot to connect a test switch paddle, which is a device where you could connect your relay test set or another current source and plug into the relay and inject test current into the relay. It also allowed you to isolate just a trip circuit if you want to do something with it there, or isolate any number of other circuits. All of the relays of this vintage, by the very nature of their construction, have the circuits from the switchgear or from the substation coming up to the bottom of the test switch, and the blades come out the front. So the stationary contacts on the relay, the guts of it, the part of it that does the protection, the stationary contacts on the top are physically on the relay. That's just how it was built. All of them are designed so that a test switch paddle can be inserted and connect the relay test set or the current source on the top. That's just the only way that the paddle works, because it's physically connected directly to the relay itself. Another cool feature, current sources from CTs generally need to be shorted so that you have a closed loop on the secondary. And if you're isolating a relay, well, that circuit can come open. So the FT cases had a really ingenious mechanism, very simple, very clever mechanism for shorting the CT circuit at the switch on the bottom blade side of the switch, so that no matter what order the switches were opened in, you never had a open circuit on your CT secondary. And again, that only works if the CT is wired up to the bottom, the blade side of the test switch. As relays moved from electromechanical, the old school FT cases, to microprocessor-based relays, newer relays that are basically a computer with a whole brain in it, we have to cram a whole bunch more I/O in it. We're getting all three phases of voltage and current to it, instead of trying to cram all of this protection and all of this stuff that we want to do with our protection relays into a small little FT case. Well, we just sort of all decided universally they're either going to be bigger cases like, the SEL 751, GE8 series, where they're substantially larger cases than the old FTs were, or going to like the substation style where they're very wide. They're mounted on like a 19-inch server rack in the control house. That's really popular too. But we still had a need to isolate our I/O, to isolate our trip circuits, to short CT circuits, all of the same problems that we had isolating the electromechanical relays that were in these FT cases. Well, we still have those now. So instead of reinventing the wheel, we just took the same exact switch mechanism from the FT case and we whacked it on the door of the switchgear, or we whacked it into a 19-inch rack mount thing for our substation, and we used the same exact switches the same exact mechanism, the same exact design, really the same exact wiring. It's just now it's a discrete component. The test switch is separate from the FT case. The design didn't change at all. The spacing didn't change. They're exactly the same. The test battle that your grandfather tested relays with still works in a brand new substation nowadays, and all of the new test paddles that are compatible with that size, with the ABB style or the Flexitest style, including the States one, those all work on the old electromechanical relays because it's all one thing. It's all designed to work the same exact way. It's great. It's been the same for literally 60 years. Literal generations of substation techs, PNC guys, and engineers have spent their entire careers connecting to relays the same exact way. So what's the problem? Well, some maybe well-intentioned engineer in the last decade or so had too much time on his hands sitting in an air-conditioned office somewhere, and he says to himself, if the PTs are connected to the blade side, when you pull the blades out to isolate it, well, now I've got an exposed, energized conductor that's going to shock somebody, or we're going to short it and blow the PTs and have all these problems and blah, 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 blah. If this soft-handed little bitch of an engineer had ever tested relays or spent any amount of time in the field, he would know that the test switches have to be that way. The bottom is always connected to the source and the top always goes to the relay because that's how the fucking test switch paddle works. Why have a test switch that isn't designed to work with a paddle? He would also know that people have been dealing with this apparent hazard since long before he was in diapers. But I don't think he spent any time in the field. He just made a decision and said, here's what we're gonna do. Since the test switch isn't physically connected to the relay, it can be wired in basically any way we want to wire it. So let's top feed the test switch with DC voltage from our PTs, trip circuits, whatever. We can top feed the test switch so that when you pull the little blades out, the little blades aren't going to shock your little fingers. Problem solved. And Captain Soft Hands goes down to talk to the guy in the green hard hat, and the safety guy, they just pat themselves on the back and give each other big old giant green stars. And then they go talk to a lawyer, and the lawyer's like, oh wow, this is a mind-blowing idea. We're gonna do this for all of our designs forever now. So the solution's way worse than the initial problem, right? Because that's not how that works at all. It's not evident to you at this point in the conversation why this is an absolutely idiotic solution to top feed the test switch. You're like, what the fuck? I want to spell it out for everyone. Number one, only people accessing electrical equipment in the first place should be trained, competent, and qualified for their task and familiar with the equipment. The only people removing the covers off of test switches need to be trained, competent, and qualified. The only people opening the test switches or putting test switch paddles in need to be, say it with me, trained, competent, qualified. All of the training required to be competent and qualified is based on the last 60 plus years of experience, where the top of the test switch goes to the fucking relay and the bottom of the test switch goes to everything else. And it doesn't even solve the problem anyway, right? Because even when the test switches are closed and the relays are in service, there's still exposed energized bits of metal there with the cover off. You haven't fixed a thing. So like, what are we even doing here? They're deciding to do things different than a long-standing convention because it feels safer. It feels better, with literally no logic or understanding behind it at all. So when a tech goes out to test a relay, and he plugs in his test switch paddles, and he puts his test leads in the test switch paddle to connect to the relay, because that's how that works. That's like why we have the thing that's there, but it's now wired wrong because you designed it to feel safer. Well, now that technician has test leads that are unwittingly hot in hand, and he's gonna be more likely to shock himself than he would if you had just wired it to the bottom and the little nubs on the switches are hot. You made it worse. A relay tech knows that the bottom of the switches are hot, right? Because That's how the whole thing has worked for the last 60 years. That's what he was trained on. That's what he's familiar with. That's what we're going to be expecting when we go out into the field. The relay side should never magically be energized. The top of the test switch should never be energized when the switch is out. And now, because you feel safer about it, what we're going to do, exactly how I started this video, we're going to blow shit up, and we're going to shock people, and we're going to hurt people because it's different from convention and it's just objectively wrong. Precisely what happened to me last week. I was working with a rep from the switchgear manufacturer at a data center. No shade on him. He's actually a lovely guy. Ian, if you're watching this, I'm definitely not mad at you. It's not your fault. I don't even have beef with his company in general. Like it is what it is. But the engineer that designed this, like just you. Like, why? What the dude? Like, why? Anyway, what happened? The rep from the switchgear manufacturer asks me, "Hey, do you want me to turn DC power on for your testing?" And I'm thinking, yeah, no, that's great. I would definitely appreciate that. I'm already kind of hooked up to it. I already got my test leads in the test switch paddle, but I haven't really started doing anything yet. One less thing for me to wire if I already have control power on the relay, right? So he walks around behind the end of the gear, turns on the DC battery bank breaker, and immediately backfeeds the battery sim output on my Doble 6150 with 125 DC from the battery, station batteries. It lets all of the magic smoke out. It doesn't work at all. There was a mushroom cloud. I had like people from 6 blocks away coming over to ask what happened. It was a nightmare. So much smoke came out, it was incredible. Guess who's got to sign the PO for the repair bill on my F6150?
I am 30 or 40 years old and I do not need this.
In conclusion, I really want to get 3 things across here. Number one, technicians, relay guys, people in the field, be aware that this dumb shit is out here. I don't care how many times you've tested relays at this point. Like this is the second job site I've seen where something has been upside down. In this case, it was just the DC power supply to the relay was upside down. Just engineers, this is a plea. Obviously, stop doing this. Don't do this to people. You're making it less safe for the people who already know how to work on this equipment. Everyone else, manufacturer reps, commissioning guys, random dudes watching this video, if your site has top-fed test switches for whatever reason, it could be a DC power source, a PT circuit, it could be a sync circuit, it could be a lockout circuit, whatever it is. If it's fed from the top of the test switch, it should go to the relay, and it's not, it's upside down, it's wrong. I'm not even saying you have to go change it, but put like a sticker, put a note, just write on there in Sharpie that it's top fed, and you're gonna save a relay tech a ton of time and effort. You're gonna keep him from getting shocked, or worse, from getting fired for blowing up a $40,000 test set. So just do everyone a favor, label it right there on the gear. So when you're plugging into it, you're like, oh, this one's top fed. I don't want to blow my stuff up. I don't want to get shocked. I'm gonna be really careful. I'm gonna look at it and make sure that I know how it's wired. It's not that hard. Fix that. Gentlemen, thanks for watching. Consider hitting the join button down below and supporting the channel for as little as $2 a month. Definitely appreciate it. I do make better, higher effort videos sometimes. I have a whole masterclass on the SEL 751. It's coming out soon-ish. Stay safe, and I'll see you on the next one.